Let us consider the following problem. A 75-gram Frisbee is thrown from a given point above the ground with given speed. When it has reached another height, its speed is given at this point. What was the reduction of mechanical energy of the Frisbee-Earth system? One of my students suggested the following solution of the problem. First, he considered Frisbee and Earth as a system, and secondly, he suggested that this system is closed. Because the gravitational force, which he considered as the only force in this system, is conservative, he decided that mechanical energy is constant. And for this reason, change of mechanical energy is zero. This was the solution of the first student. Another student decided to use definition of mechanical energy as the sum of kinetic energy plus potential energy. In this case, change of mechanical energy is the sum of changes kinetic plus potential energy. Then she represents change of kinetic energy as final kinetic energy minus initial, and for initial kinetic energy she used this equation where V1 is the speed of Frisbee at initial point. For final kinetic energy she used this equation with V2 the speed of Frisbee at final point, and in this case delta K is equal this expression. Similarly, she calculated change of potential energy. Initial potential energy is equal mgh1, final potential energy is equal mgh2, and the difference is given by this equation. So all numbers we know, they are given here, and we can plug in delta K and delta U in this equation and make calculations. As a result, the change of total mechanical energy is equal negative 0.53 joules. Which answer is correct? The answer of the first student or the second one? And why the calculated change of mechanical energy is negative in our case, if this solution is correct? Let's think a little, and then we will review the right solution. Let's return to the solution of the first student. As you remember, he selected the system consisting of Frisbee and Earth. He has a right to do this. We can select the system as we want. And next, he claimed that this system is closed, and this was a mistake. The system is not closed. Why it is so? It is so because in addition to Frisbee and Earth, there is here air. And this air creates a force on the moving object. This force points in direction opposite to velocity of the object and makes a work on the Frisbee, changing its mechanical energy. And this actually force is a frictional force. It's called drag force. And for this reason, mechanical energy is not constant. Frictional force is a non-conservative one. According to mechanics, change of total mechanical energy equal work which is done by external force, and in our case external force is drag force, and this work is negative, and this is confirmed by the fact that our calculated change of mechanical energy is negative. For this reason, the solution of the first student is incorrect, and the solution of the second student is correct. So, the problem is solved completely. If you like this video, you may want to click like button, leave a comment and subscribe to the channel.